This is Dr. NIRUPAMA Bhatt from the Department of Computer Science and Engineering. As a part of our information security course, today we will be dealing with block cipher modes of operations. Why we need to have this block cipher modes of operations? We have seen the DES, AES algorithms, which are symmetric cipher algorithms. So, to enhance the effect of these particular algorithms in various applications, we have to go for this modes of operations. So, a mode of operation, it is a technique for enhancing the effect of the cryptographic algorithm when you are applying this particular algorithm on various applications. This algorithm, this block cipher modes of operations, there are 5 types of operations. Let us see them. They are electronic code book, cipher block chaining, cipher feedback mode, output feedback mode and counter mode. They are electronic code book, cipher block chaining, cipher feedback mode, output feedback mode and counter mode. Now, we will see each of these operations and we will see the advantages as well as the limitations and working of these particular modes of operations. The first one is electronic code book. Let us see how it works. So, suppose we have a plain text of any length. If we are using DES algorithm, we have to divide the plain text into block of 64 bits. If you are using DES algorithm, you have to divide the plain text into block of 64 bits. So, like that, after splitting the plain text into block of 64 bits, if there is a last block which does not have 64 bits, then you can pad it with some other bits so that it reaches the 64 bits. Here you can use any of the algorithm for encryption, but it should be a symmetric cipher algorithm. So, you can use either DES or AES algorithm. So, and you are taking the key, and when you take the plain text and key as input to the encryption algorithm, you come up with the cipher text. So, like that, individually you will be encrypting the different parts of the message which you have divided them into different blocks. So, for the next part of the message, again using that same key, you will be applying the encryption algorithm and you will be getting the cipher text. So, if there are n blocks, the same process is applied and you will be getting the different blocks of cipher text. In the last, you can combine all the cipher text. Let us see how the decryption will be done. The same decryption, it is the reverse process. You take the ciphertext block and the key as input to the decryption function so that you get back the plain text. The same process, the way you have divided the plain text, here you are dividing the ciphertext into blocks of 64 bits if you are using your DES, otherwise 128 bits if you are using your AES algorithm. So, like that we can divide them into multiple blocks and apply the encryption and decryption algorithm. That means the receiver, he will be applying the decryption algorithm and the sender, he will be applying the encryption algorithm. So, here we need to see one more thing. Yeah. So, you can write the notation like this: if E is the encryption algorithm and K is the plain text and Pi is the ith plain text block, then after applying the encryption algorithm, you will be getting the ciphertext. Like that, when you have n different blocks, you are applying for n different blocks, one after the other. Coming to the decryption, the same thing, it is the reverse process. So, you are using the same key and the ciphertext as input to the decryption algorithm and you are getting back the plain text. If there are n blocks of plain ciphertext, you will be getting it back into n blocks of plain text. So, let us see, now we will see the working and benefits and disadvantages of this particular algorithm. So, the plain text as I have told, you are dividing that into blocks of n bits, and if the last block, if it is not complete, you will be padding it with the dummy bits, and we are encrypting each of the block independently. Here the main disadvantage is this, the identical plain text. If the two blocks have the same plain text, then it will give the same ciphertext. So that is one of the disadvantage we can say. So identical plain text leads to identical ciphertext, but it is very simple and easy to implement, and this is suitable for sending small messages. Why? Because if the message is large, you may get identical blocks of plain text, and this may lead to identical blocks of ciphertext, and which may give a chance for cryptanalysis. Now we will see the next mode of operation, that is cipher block chaining. Cipher block chaining, here it is same as the previous one, we have some difference here. Similarly, you are dividing the plain text into blocks of 64 bits. If you are depending upon the algorithm, if you are using DES, you will divide it into 64 bits. If you are using AES, you will be dividing it into 128 bits. So you are taking the plain text. Here you are coming up with a new notation, IV. IV is nothing but you call it as a initialization vector, and this initialization vector is some group of bits that has to be known both to the sender and the receiver. You need not keep the initialization vector as a secret, but it should not be changed between the sender and the receiver. Both of them have to use the same initialization vector. So you are taking the initialization vector which is known both to the sender and the receiver, and now we XOR the initialization vector with the plain text. Here we are trying to increase the complexity of the algorithm. So instead of directly sending the plain text to the encryption algorithm, we are XORing the initialization vector with the encryption algorithm, and the output you call it as the ciphertext. Okay, but instead of using again the plain text in the second block of plain text, what we are doing is, as per the name, cipher block chaining. That means we will chain the output of the first block to the second block. Here we are using the initialization vector, and here we are using the cipher block of the first block. Okay, and we are XORing it with the plain text. Again, the output of that is sent into the encryption algorithm, and using the same key, because this is a symmetric cipher algorithm, both the sender and the receiver uses the same key, and we get the ciphertext. Again, this ciphertext will be sent to the next plain text block. So the ciphertext is chained from one block to another block, and finally all the ciphertext together will be the ciphertext that will be reaching the receiver. At the receiver side, again he has to decrypt it. So let us see the notation here, what we have done. First we have initialization vector. We are XORing the initialization vector with the plain text. So you are XORing the initialization vector with the plain text. Okay, and next you are encrypting that particular data using the key K, and you are getting the ciphertext. That is, in the first round you are using initialization vector, in the next rounds you are using the ciphertext of the previous round to XOR it with the plain text. Now let us see how the decryption works. It is reverse of the encryption. So the same figure you can, same logic in the reverse order we have to use. So let us see here. So in the previous one you have just encrypted some data to get the ciphertext. So you are taking the ciphertext block, and you are sending that ciphertext block to the decryption algorithm, and both the parties will be using the same key, and whatever you get from the decryption algorithm, you are XORing it with the initialization vector to get back the plain text block. So this is done at the receiver side, and again the particular ciphertext has to change to the next block. Again, the previous block ciphertext will be changed to the next block, and the next block ciphertext, again it has to be taken and decryption algorithm is applied with the help of the key, and the output is XORed with the ciphertext of the previous block to get back the plain text. And this process continues for all the n blocks of ciphertext, and together all the plain text together we call it as the plain text message. He will be retaining or getting back the message. So, let us see the notation here, how it works. Yes. So, here we have what we have done in the first step is you have taken the ciphertext block and you have applied the decryption algorithm using the key. So, you have taken the cipher block text, applied the decryption algorithm using the key, and then you have XORed with the IV. In the first block you are XORing it with the IV, and in the next blocks you will be XORing it with the previous block's ciphertext, and this will be done from 1 to n blocks. So, this is about the cipher block chaining. So, let us see some more points regarding the cipher block chaining. So, here if you have identical messages also, you do not get the identical ciphertext, because you are not only applying the algorithm on the plain text, but you are performing some XOR operation on the plain text to get the ciphertext. So, the identical messages result in different ciphertext. It does not come up with the same ciphertext. And chaining, what we are doing, we are chaining the previous ciphertext block with the plain text block. Because you are chaining here, if there is a small error in the previous block's output, that particular error will be propagating throughout all the other blocks. Suppose there is a small error here, there is a small error in this particular ciphertext, suppose, and this ciphertext during the transmission you have got an error, or during the calculation you have got an error. The same thing will be transmitted and the errors will be transmitted to all the blocks. So, that is one of the limitation of this particular algorithm. And the IV, that is nothing but the initialization vector, it need not be secret, but its integrity should be protected. That means it should not be changed between the sender and the receiver, and it is suitable for sending long messages also. Why it is suitable means, here the identical message does not result in a identical ciphertext, because though the message is identical, it will be changing. So, it is suitable for sending long messages. The third mode of operation, it is cipher feedback mode. The cipher feedback mode. So, this operation, it can be used both for block ciphers as well as the stream ciphers. Previously, the electronic code book and the cipher block chaining methods, they can be applied only for block ciphers, but this it can also be applied for stream ciphers. I will just remind you, block cipher means you will take a block of plain text and you will apply the algorithm, encryption algorithm on the plain text block to get the ciphertext block. And stream cipher means you take a stream of cipher, it could be few bits or 1 or 2 bytes or single byte. Every byte will be encrypted and it will be converted to ciphertext and it can be transmitted. You need not wait for the data to become a block. Okay. So, in mainly the real time applications, or when you are sending the data using the World Wide Web, this particular stream ciphers are used for encrypting. So, now this is cipher feedback mode. So, let us see what is happening in this cipher feedback mode. Here till now what we have done is, we have used the plain text here and you have applied the encryption algorithm on the plain text. But in this cipher feedback mode, we are not using the plain text and we are not sending the plain text into the encryption part at all. We are not performing any operation on the plain text as input to the encryption algorithm. So, you take the key and the initialization vector. Here also we use an initialization vector which is known both to the sender and the receiver. This initialization vector with the key together, you send it to a encryption function and you are getting the output. This output of the encryption function, the whole output you won't be using. You will take only the most significant S bits. You will take only the most significant S bits of that particular output and you will be XORing it with the S bits of plain text. So, if you are using 8 bits of plain text, you take only 8 bits of output. If you are using 16 bits, you will take 16 bits. Depending upon the plain text, you will be using the number of bits here, but it should be some constant value. So, it can be 8, generally it will be 8. So, you are XORing the output, that is S bits of the output. You do not use all the bits, you use only at S bits of the output with the S bits of the plain text. You perform the XOR operation and you get the cipher text, and this cipher text is again changed to the next block. How it is being changed? Here instead of IV, you are sending it as input to the shift register. In the shift register, what happens means, you are sending the output, that is the cipher data, into the shift register, where you take this S bits and you left shift this, so that you left shift S bits and you add it to the end, and this will be the input to the encryption algorithm as well as using the same key. And this same thing, you are getting the output, again you are taking only S bits of plain text and you are applying this output, S bits of the output, first S bits, that is most significant bits, and you are performing the XOR operation. So, this will be continued, so till the last plain text data, or it can be continued. So, mainly it can be used both as block cipher and stream cipher depending upon the value of S. Suppose if you are considering the S bits as 64 bits, you can consider it as a block cipher itself. If you want to use smaller number of bits, you can consider this as a stream cipher. So, let us see the notation. Here we are representing X as the shift register and S of X is considering the most significant bits of the shift register, and you are encrypting the, here I have used for shift register, and initially it is initialization vector. So, you are encrypting the initialization vector with the key and you are XORing it with the output. You are taking only S bits of the output and you are XORing it with the plain text to get the cipher text. So, for the same process, it is being continued in the other blocks. So, the decryption is also same. One thing you have to notice, in the previous modes we have used the decryption algorithm, but here for decryption we do not use decryption algorithm because we are not sending the plain text into the encryption algorithm. If you are sending the plain text into the encryption algorithm, then you have to send the data to the decryption algorithm. Because you are not sending the plain text into the encryption algorithm, you need not, you should not, it is not need not, it is should not use the decryption algorithm here. For decryption also you have to use the encryption algorithm. So, you are taking the same process, initialization vector, key and the output, you are taking only S bits of the output and you are XORing it with the cipher text S bits. You are XORing it with the S bits of cipher text to get back the plain text. Again, the S bits of the cipher text, it is sent into the shift register where S bits are moved the other way, it will be lost and the new S bits will be joined here, and again you are applying that on the encryption algorithm. That means whatever part you have done in the encryption process, the same thing is repeated, because you are not using the plain text here as input, but you are using plain text only in the XOR operation. So here we are encrypting it, and the output of this, again you are taking only S bits of the output and XORing it with the S bits of the cipher text to get back the S bits of the plain text. And this process, it is continued for the remaining n blocks or bytes, whatever it is. So the next one here, it uses the shift registers of size 64. So it is suitable both for the block and stream cipher, and this mode, it uses only encryption algorithm. This is very important for both encryption and decryption process, and character wise or bit wise encryption can be done, but preferably character wise. And here also the error is propagated, because you are propagating the cipher text as the input into the shift register, and it is used in real time applications. And the fourth one, it is the output feedback mode. It is almost same as our cipher feedback mode. There we chain the cipher, but here we do not chain the cipher, we chain the output. So let us see. Again you have the initialization vector, you have the key. So here also you are not using the plain text. You are not using the plain text as input to the encryption algorithm. You have to use the initialization vector as input to the encryption algorithm, and that initialization vector is known both to the sender as well as the receiver, and the key should be kept secret among only sender and the receiver, and there is no problem if the IV is known to others also. And you perform the encryption process, and here you are getting the output. Actually we are XORing the output to get the cipher text. You take the most significant bits and you XOR it with the plain text to get the cipher text. But there what we are doing, we are sending this cipher text to the shift register, but here we are not sending the cipher text data to the shift register, but we are sending only the output, that is before XORing whatever data you have got, only that S bits you are sending it to the shift register, and that again that is taken as input to the encryption function, and the same process will be continued. You get the output, and to get the cipher text you XOR the S bits of output with the S bits of the plain text to get the cipher text. And so if you can guess correctly, in the decryption also, in this also you do not do the or do not use the decryption algorithm. In the decryption also you use encryption algorithm only, and this is the notation how you have reached with this particular work. So you are taking this is the initialization vector for the first block, otherwise it will be the shift register data. So you are encrypting that data, and you are XORing the most significant bits of the shift register with the plain text to get the cipher text, and the same process will be continued with the other blocks. This is the decryption part. I have told you here also you are not going to use the decryption algorithm, the same process, but here previously you have used the cipher text, but here we have to use the output value, that is all. So you have the initialization vector, and that is sent as input to the encryption algorithm, and the output S bits you are sending it to the shift register of the next block, and you are taking S bits. This is decryption now, so you are using S bits of the cipher text and XORing it with the output of this encryption algorithm, and you are getting the plain text. Here also the same, you are taking the ciphertext, S bits of the ciphertext and XORing it with the output of this particular encryption algorithm to get back the plain text. So, it is just a reverse process, and here also you will not be using the decryption algorithm. So, the notation, it is same, the things are same, but here because you have to get the plain text, you are XORing it with the ciphertext. To get the ciphertext, you have to XOR it with the plain text, and this one, it is suitable for stream cipher, and here you do not need padding because you will be generally taking it as character wise, and it is suitable for real time application. Again, the same algorithm has to be used both for encryption and decryption, and if the ciphertext is corrupted during the transmission, still you do not have any problem, because here you are not sending the ciphertext to the next block, but you are sending only the output of the encryption algorithm to the next block. So, you can come out of that problem, and text can be encrypted and decrypted in parallel also. Okay. And the next one is counter mode. Here the sender and receiver both will think one number, and it can start from 0 or they can start with some number, and they will initialize the counter with that particular number, and that is encrypted using the key, and you get the data and you XOR it with the plain text, so that you get the ciphertext. And again here all are different, so there is no connection between the previous block and the next block, so you can perform these things parallelly also. So, in the next step, you are incrementing the counter value and you are again encrypting that counter value with the key, and you are XORing it with the plain text to get the ciphertext, and this process continues with all the blocks. So, this is just very simple. You are applying the encryption algorithm on the counter value, and the output you are XORing it with the plain text to get the ciphertext. So, in the decryption the same thing you will be doing, but you will be XORing it with the ciphertext to get back the plain text. The same repeats, XOR with the ciphertext to get back the plain text. So, here you can see you have the counter value, the same counter has to be used both by the sender and the receiver, again sending it to the encryption algorithm, and here you are this particular output, it is this way you have XORed with the ciphertext to get back the plain text. So, the same thing here. Okay. So, these are the various modes of operations. So, finally, we can say that this is for decryption. In the decryption, we are sending the ciphertext to get the plain text. In encryption, we are sending the plain text to get the ciphertext. So, the counter, it has to be initialized first, and its value is incremented 1 with each block, and encryption and decryption can be performed parallel because there is no connection between the different blocks, and you can use that in IP security protocol. You have different protocols in the various applications, you will be using different protocols at different layers. You have one called IP security, in that you can use this counter mode. So, finally, in this particular session we have seen why you need a block cipher mode of operation to enhance the ability or working of the algorithm. You are using some technique called modes of operation. That means the same known algorithm you are using with some additions, so that the complexity of the algorithm is increased. So, you have seen some algorithms, 2 of these modes of operation, they are only for block cipher, and few are only for stream cipher, and some it can be used both for block cipher and stream cipher. So, thank you very much.